Hi, so today we'll be solving a LeetCode medium problem, beautiful arrangement 2. This is not any extension of beautiful arrangement 1. That problem is totally different. So let's go through the problem statement once. So like we are given two variables n and k, and we need to construct a vector. Means we are given n and k, and we need to create a vector of like size n, which has all the distinct integers from 1 to n. So it has all the distinct integers from 1 to n, and it also follows this condition that we are given, like all the adjacent differences, for example, b1, then we have b2, and so on, that we will get bn minus 1. So these differences array that we get means it should only have k unique integers, means k unique or different integers. So we need to construct or return a vector which satisfies this condition, and if there are multiple valid answers, we can return any of them. But as we can see in the constraints, the constraints are of the order of only 4. And if we try for all the possible permutations of these n numbers, that will be of the order of n factorial, and hence means the constraints will not allow it simply. So we need to means greedily find out some constructive algorithm to satisfy the condition. So here this means we can traverse through all the permutations and see if that permutation satisfies the given condition and return it. But that would only be feasible if n was of the order of like 15, means 15 to 16. So here, for example, if we are given n equals to 3 and k equals to 1, a beautiful arrangement is 1 to 3, because difference of 2 and 1 is 1, and 3 and 2 is also 1. So there is only one distinct integer. For example, here it can be 1, 2, 3. This gives us as 1, and this gives us as 1 only. So there is only one different integer in this side, and k was 1. So hence this is a correct output. Then we had another example, n equals to 3, k equals to 2. So for example, suppose we have n equals to 3 and k equals to 2. So one correct output is this. Here we have the difference as 2, and here we have difference of 1. So generally, like in these kind of problems, we means need to make some observations and like greedily try, means using a trial and error mechanism, we try to find out some possible way of arranging these numbers. So like for example, suppose to go in that flow, suppose I fix the first number. I fix the first number as 1, and then try to means make the remaining array. So, for example, if means only on the basis of k, for example, if k was 2, I fix the first number. Now, what are the possible configurations of second number? It can either be 2 or 3. But what if, since k is 2, I cannot put 2 here, because it will be 3, and the difference array will only contain 1 and 1, which only has one different integer. Hence, 2 will not put 2 here, we will put 3, and then only remaining part is 2. So this, suppose we had k equals to 3 and we fixed 1 here. Now we need to fill 3 positions. Possible scenarios for this is 2, 3, 4. Now since k equals to 3, the maximum means if n was 4, since k is less than n, in the worst case, the value of n can be 4. It means the maximum value of k can be n minus 1. And if maximum value of k is n minus 1, then in that means we need to take the difference of elements 1 and n, right? Because like if k is n minus 1, for example, k equals to 3 here, and n is 4, then to have three different integers in the difference array, we need to take the difference of 1 and 4 in the worst case. So this means gives us a hint, like if we fixed 1 here, and we can simply put the second value as 4 only, right? Now we have two positions to fill. and we needed three different integers in the difference array. So this 3 is already satisfied. Okay. Now we need 2 and 1. Now from 4 we cannot move ahead because n is 4 only. So either we can go back by 2 or go back by 1. Now why going back by 1 is not feasible? Because if we go back by 1, then 3, then we only have 2. So again the difference will be 1 only. And here the difference will be 1 only. So this 2 condition we will not be able to satisfy. Hence we go back by 2 steps. Now we go back by 2 steps, then we move forward by one step. Right? So we move forward by 1 step. So what we can try to see is we move forward by k steps, then we move backward by k minus 1 steps. So we move forward by k steps, we will decrease by k minus 1 steps. Then we move forward by k minus 2 steps. And similarly then move backward by k minus 3 steps. So if we try to like follow this kind of algorithm, we will be able to means satisfy the condition using only k plus 1 numbers. So even if like for example, even if uh, n was much greater than k, we will be able to satisfy the condition using k plus 1 numbers only, and then we can simply arrange the remaining numbers in k plus 2, k plus 3, k plus 4 and so on till n, and it will not produce a new different integer because all the differences will be 1 only, and we have created integers with these differences k. Okay, so using k plus 1 numbers we can create a new difference array which has k distinct integers, and how we can do this is we fix the first number as 1. Now we need these differences. So first we need a difference of k. So we will move by plus k. Okay. So we will get k plus 1. Okay. Now we need a difference of k minus 1. So since going ahead is not feasible, we go backwards by k minus 1. Okay. So k plus 1 minus k minus 1. K plus 1 minus k plus 1. So it is 2. Alright. Now, since we have moved satisfy k minus 1, we need to satisfy k minus 2. So we move forward by k minus 2. So we get k only. Then we move backward by k minus 3. So we'll get 3. So are you able to see? Like we'll get this pattern 1, then 2, then 3, then here will be 4, then here will be 5, and so on. Then here will be k plus 1, then k minus 1, then k minus 2, then we have k minus 3, then 6, and so on. And using only n numbers, we would have satisfied the condition using only k plus 1 numbers. Alright. And after that, we can simply put these k plus 2, k plus 3, and so on n numbers here. And what will be the number just before k plus 2? It will not create a difference, means k plus 2 minus some number x which will be present here. Will it create a difference greater than k? Means if it creates a difference greater than k, then we have k means y. Suppose it is equals to y. Then we have a new distinct integer. But is it possible? It is not, because to get a difference greater than k, we need to take difference of k plus 2 with k plus 2 with 1. Okay. And since 1 is at the start, we'll never be taking this difference of k plus 2 with 1 equals to k plus 1. So hence we will be able to satisfy this condition of arranging these numbers in an increasing order of k plus 1, 2 to n, and following this pattern for the first k plus 1 numbers. Since it is a constructive problem, there are obviously multiple solutions. This means was the approach which came into my mind as I observed the question. There may be multiple ways to solve this, but this is also fine. So we can like move to the implementation part of this as well. So we will create a vector resultant, and initially we'll have the resultant as 1 only, and we'll try to fill the remaining positions. Now I have created this flag variable so that first time I increase, then when it is false, we will negative. Then we will move forward, otherwise we will move backward. So uh, first time we move forward by result dot back. Initially it was 1, so result back plus I. So we move by plus k, and then we make this flag as false, so that next time this condition is executed. Now next time the k minus 1, so we'll be moving backwards from k plus 1. We will be moving k plus 1 minus k minus 1, and so on. We will follow till 1, and then all the remaining numbers, like once we have these k plus 1 numbers here, we'll put these k plus 2, k plus 3, and so on till n in the end. And this will like I think will satisfy the condition that we need to follow. This I am repeating again, this might not be the only solution that we can find, but yeah, in constructive we there are multiple solutions possible, and we just need to find out the one. So you can either follow that or try to derive something of your own as well. So I will just try to execute the code here. So uh, this runs fine, and yeah, and it also beats 100% of the users, and the time complexity is big of n only. So yeah, if you have any doubts, don't feel free to comment, and yeah, thank you.